Okay, there are a number of important situations that arise in Chapter 5, which is coming up. I guess the first assignment's due in 2 days, okay? And what the problem says, I've been through all the problem sets and see what they do. I don't remember what's in each one as opposed to the other, but I'm going to kind of address the whole thing. And, if I'd have remembered that the lab stops, uh-oh, it just went off. Back on? Yeah, okay. Why was it on for that long? Got to reset power options. No big deal. Let me plug it in. Okay, I would be able to separate that out if I had stuff pulled up that I thought I had pulled up, but it's been rebooted. Okay, so mass on the incline, what do we got? You got gravity acting downward. We've already seen this. We got the normal force acting perpendicular to the incline. Okay. We'll typically have a frictional force. Okay. And we might have some other force, maybe a horizontal force acting in. So we have an applied force. In this case, you want to do everything in a coordinate system where the x-axis is parallel to the incline. Because in that case, the normal force is in the y direction. The frictional force is in the x direction. The gravitational force resolves into components parallel and perpendicular to the x direction. Okay? So parallel and perpendicular to the direction down the incline. The applied force, well, in this case, if your x-axis is here, if you know the angle of the applied force, then you can find its components if you're given the force, and if not, you can say that, well, the x component is applied force times the sine of theta and so forth. The y component times the cosine of theta. Then you'll be able to write the forces, the x forces. And the y forces, okay? Just be able to list them down here. And then the sum of the x forces is 0 if it's in equilibrium. Okay? Maybe or maybe not. The sum of the y forces is always 0 if a thing stays on the incline. If it stays on the incline, it has no acceleration perpendicular to the incline, and that's your y direction. Okay? So big deal here. Sum of the y forces is 0 if the block stays on the incline. Now the rest, if you understand that much, is just a matter of writing out the components of the forces in the x direction, the components in the y direction. The sum of the y forces is 0. That's going to give you information. You got to get a couple of simultaneous equations out of this, okay? And you just need to work through the details of that. And you're going to do that in the homework. I don't need to show you that because the homework is going to develop that in a very nice way. And then if you run into problems, and I see problems on the work I see, then we address those problems in class, okay? Give you the basic principles. Open Math will give you the basic principles. You read the textbook. That'll give you the principle. Okay. Now, Atwood machine. What do we got for the Atwood machine? Well, generally, pulley's going to be frictionless in all three of these cases. So, what forces are acting on this mass? Okay, well, let's think about it a little bit. Now I'm going to turn this off and we're going to talk about this one, okay?